Today, we're going to take a look at the last section in the first module, writing equations of lines. For this first part, we're only going to take a look at about half of the material, but in this particular section, when we first start talking about equations of lines, the first thing that we need to talk about is slope. And in the first couple of pages of this unit, you will see information about the slope. First of all, by definition, we're talking about the direction a line takes. Does it go up? Does it go down? Just like in real life on a road. Does the road rise up? Does the road go down? Is it completely flat? Or in real life, we don't think of roads as going straight up, but in geometry or algebra, lines can go straight up. So the direction that the line takes is called the slope of the line. We have four different slopes. We have positive slope. Positive slopes are lines that move, that rise from left to right. We read from left to right, so we look at the lines as we move from left to right. If the line goes up as you move from left to right, so if I start here and I move up as I move to the right, then it's said to have a positive slope. Opposite of that is a negative slope. Lines with a negative slope fall from left to right. In other words, they look like they're going down. So if I started at a particular spot, if it went down as I moved from left to right, it's said to have a negative slope. Then we have lines that have a zero slope. And in this case, zero is a value. It's not a nothing, it's a value. And a zero slope line means that it does not rise. It doesn't move up at all. It is said to have no change in its elevation and no change in any vertical movement. So a line that doesn't have any change in its vertical movement just is straight like that. Now, opposite of that, just like opposite of positive slope is negative slope, the opposite of zero slope is said to be no slope. And the same thing, if a zero slope does not rise, doesn't have any vertical change in it, something that has no slope has no horizontal change. And lines that have no horizontal change just go straight up. Now, a little bit clearer picture as to what they work with. So to take a look at a closer picture, those positive slopes, again, move up and to the right because they rise. So when we look at that, we are actually doing two movements. We're starting at a particular place and we're moving up, and then we're also moving to the right. So we have a vertical movement combined with a horizontal movement. So when we do our slope, it's actually a fraction and it's a comparison between those two movements. So it's a vertical movement on the top and a horizontal movement on the bottom. And when a line rises, that means this fraction simplifies to a positive fraction. So it may move up, which is positive, and then move to the right, which is also positive, or it may move down and it may move to the left. But if you take a look at those, if you started here and you moved up and to the right, you have a line that looks like that. If you started here and you went down and to the left, your line looks the same. It rises. Negative is just the opposite of that. A negative one, the line falls. So its vertical movement will be down and the horizontal movement will be to the right. So again, the vertical movement will be down, the horizontal movement will be to the right. Well, down is negative, right is positive. Well, negative and a positive make a negative slope. Zero slope, where we said before a zero slope was a slope that had no vertical movement at all. So it didn't go up or down at all. So if I started here and I don't move up or down, then the only way I can go is this way. Well, that's a horizontal line. So horizontal lines have zero slope. And then the last one, which was a no slope means that there wasn't any horizontal movement. So you start here, but if you don't move horizontally at all, if you don't go left or right at all, that means you're either going just straight up or just straight down. So no slopes are vertical lines. So now that we have the basics of slope, let's take a look at figuring out how we can find the slope. Now, most of the time, you're going to be given ordered pairs, but you might be given a graph. So let's take a quick look at graphs. And the graphs are super easy because all you're going to do is count. So let's say I have 1 point here, and I have another dot over here. So remember, slope, and the symbol for slope is M. It's the vertical movement compared to the horizontal movement. Vertical's on top, horizontal's on the bottom. Well, we go from left to right because that's how we read. So you start here, and the only way I can get to this dot is to move down. So I move down 1, 2, 3, 4 spaces. So my vertical movement was down 4 spaces. So down is negative 4. So I'm right here, and now I move 1, 2 spaces to the right. Well, 2 is, or to the right is positive, positive 2. And then all you do is reduce that. The slope of this line is negative 2. You can write it negative 2 over 1 if you want to. So if you're given a picture, a graph, all you have to do is count the spaces as you move from the left-hand dot to the right-hand dot. And remember, you always do the vertical movement first and then the horizontal movement. Now, the other way that you will be given problems will be in ordered pair form. We'll call our ordered pairs x1, y1, x2, y2. Slope is still m. Well, on a graph, and you remember this from Algebra 1, on a graph, the x numbers are horizontal numbers. The y numbers are vertical numbers. So if my slope is supposed to be vertical over horizontal, then that means I have to do the vertical numbers first. Well, the vertical numbers are y1 and y2. Well, the only way that you find the distance between two numbers is to subtract them. Like if I want to know the distance between 7 and 10, I just go 10 minus 7 and I get 3. So there's 3 spaces between 7 and 10. So you're going to do the same thing here. Now it doesn't matter whether I take this number and subtract that one or the other way around. Most of the time you'll just look at the numbers and pick the easiest subtraction to do, taking into account negatives. So we're going to write it y2 minus y1, and then on the bottom, the horizontal movement, x2 minus x1. And the only reason I did that is every time you see a slope formula, it's always written in that order. You won't see it written y1 minus y2, but you can still do the subtraction that way. Okay, so for example, let's say I have the ordered pair 3, negative 5, and the ordered pair negative 2, 7. This is an x number, this is a y number, x and y. Doesn't matter which one you put the ones next to or the twos. So we're going to do the y's first because that's the vertical movement. So I can either do negative 5 minus the 7 or the 7 minus the negative 5. It doesn't matter. Most people like the positive number to be first. So when you're doing the top, you have a choice. When you do the bottom of the fraction, you don't. So I can put the 7 first. 7 subtract negative 5. But because I use the 7 first on the top, that means I have to use the negative 2 first on the bottom. I have to use the same ordered pair. So on the bottom, I would have negative 2 subtract 3. So I get to pick the number I use first on the top, but I don't get to pick the one on the bottom. And now we just simplify. And you remember from Algebra 2 that subtract a negative is the same as adding. So 7 plus 5 is 12. And a negative 2 minus 3 is negative 5. So the slope of this line is negative 12 over 5. The negative sign ended up on the bottom, but it really just makes the fraction negative. That means that this line, if you leave the signs where they are, the vertical movement was 12. So it went up 12. Let me move this. It went up 12. But then it was a negative horizontal. Negative horizontal is to the left. So this line actually started and went like that. Because it has a negative slope, it should be going down, and it does. Okay. Let me show you another example when you get the 0 or the no. Let's do the ordered pair 3, 5, and the ordered pair 8, 5. Okay. X, Y, X, Y. We do vertical numbers first on the top. The verticals are the y's. So I'm going to go 5 minus 5. And on the bottom, 8 minus 3. Well, 5 minus 5 is 0. 8 minus 3 is 5. Any fraction that has a 0 on the top is equal to 0. So this is a line that has a 0 slope. And if you remember from earlier, if it has a 0 slope, it's a horizontal line. And let's look at it. The number 3, 5. There's the point 3, 5. 8, 5. Kind of cramped in here. There's 8, 5. Horizontal line, which is what it's supposed to be. Now the last piece. Negative 2, 4. Negative 2, 0. We subtract the y's first. So 4 minus 0. And then negative 2, subtract negative 2. 4 minus 0 is 4. And again, a subtraction with a negative becomes addition. So negative 2 plus 2 is 0. Well, another thing that you learned a long time ago was that you're not allowed to have a 0 on the bottom of a fraction because you cannot divide by 0. So that means that this fraction has no value to it whatsoever. So we say no slope. We don't make it 0 because that fraction is not equal to 0. We say it's a no slope. That means it should be a vertical line. Well, if I look at this point, negative 2, 4, and negative 2, 0, there it is. It's a vertical line, which is what it's supposed to be. All right. As you move through, that material took you through page 3 of the lesson. If you move on to page 4, they talk about a couple of other things that are true about lines. There are x-intercepts and y-intercepts. To intercept something means to cross over it. Like you have an intersection in a road. So where Bristol Road intersects Saginaw Street, that intersection is where the two cross. Well, the same thing is true here. X-intercepts are where the line crosses the x-axis. Y-intercepts are where the line crosses the y-axis. So if I have a graph, here's the x-axis and here's the y-axis. If my line crosses the x-axis, that point is called an x-intercept. Where it crosses the y-axis, that's the y-intercept. The lines that you do will have either just an x-intercept or just a y-intercept, or it'll have both. Negative sloped lines will have two intercepts. Positive slope lines will have two intercepts. Horizontal lines only have one intercept. And vertical lines have only one intercept. So those are just some other characteristics of lines. Then as you move on to page 5 talks about how to write the equation of the line, which is the main theme of this lesson, writing the equation of the line, the first thing that we're going to do is look at what's called slope-intercept form. Slope-intercept form is the form that makes use of the slope, which is m, and the y-intercept. We rarely use the x-intercepts to find equations, but we use the y-intercept a lot. The basic form for slope-intercept, and this is all in your material on page 5, the basic form, y equals mx plus b. This is the slope. This is the y-intercept. So you are either told what those two values are and you plug them in, or you have to figure them out and then you plug them in. The x and the y are actually just variables, but they represent points on the line. Every point on your line has an ordered pair, and every ordered pair has an x and a y. But when you're putting your equation in slope-intercept form, you'd never put any numbers in place of the x and the y. Your final answer will have those numbers or those letters left there. Okay? So, if you take a look at page 5 of your material, there are a couple of examples there. And if you look down at the bottom there, practice number 1 says, use slope-intercept form to write the equation of the line that has a slope of 2 and a y-intercept of 0, 5. And as you're going through this, you should have your dashboard open and you should be on page 5 so you can see what problem I'm doing. Okay, we have y equals mx plus b. To write the equation in that form, you have to have the slope, you have to have this, and you have to have the y-intercept. Well, we have the slope. It's a 2. So you put a 2 there. And again, remember, the x stays in the problem. And then if you have the y-intercept, that's what goes in place of the b. This y-intercept is 5. Now, if you think for just a second and you visualize it, the point 0, 5 is right there. That's on the y-axis. That's what it needs to be in order to be a y-intercept. So I just want the 5. I don't want the 0. I just want the 5 because it crosses at 5. So there's the equation of my line. Practice number 2 gives you a graph. So what you have to do on the graph is we have to look for that information. They're not making it easy for us. So we're going to look for the information. And if we look at the information, at the graph, looks like this. Okay, it looks like the line goes right through here. And actually, because graphs are kind of hard to read sometimes, the problem also already tells you the slope is 1. And if you pay attention to the graph, it's pretty easy. This, it crosses right here. If you go up 1 and over 1, you're right on the line. So your slope is 1. Now, the other piece of information you need in order to use this equation, remember, you need the m and the b. The other piece of information you need is the y-intercept. Well, this line crosses the y-axis right here. And that number is 0. So now we just plug the numbers in. Again, remember the x and the y stay. So y equals m, which is 1, x stays, plus the b. Now, some of you right away might say, well, do I need to write the 0 there? The answer is no, you don't. Somebody else might say, do I need to write the 1 there? And the answer is no, you don't. You need to read the directions because sometimes maybe they will want you to write it, but you don't have to under general circumstances. Okay. Let's look at example number 3. Example number 3 is also a graph, and it looks like this. It looks like it crosses right there. And it goes looks like it goes right through here. Okay. So the first thing we need to do is find the slope. So what we're doing, because we weren't given the slope, we do have 2 dots on our graph. I have to go make a vertical movement because I'm going to go from this dot to this one. So my vertical movement is down 1. So down is negative. And my horizontal movement is 1, 2, 3. Vertical over horizontal. My y-intercept is the place where the line crosses the y-axis. Well, it crosses right here. And that number is 1, 2, 3, -4. So your equation, the y stays in the problem, then the m, -1/3, the x stays, and then the b. So -1/3 x -4. Okay. Last one. Example, practice number 4. Practice number 4 doesn't give us much of any information, but it's a graph again. And it happens to be a graph. I'm not going to spend a lot of time making it detailed, but it's a line that looks like this. And they have 2 dots on it. The first one is the dot 2, 304. So now you know why I didn't draw it. And the other one is 5, 780. I think so, if my glasses or my eyes are good. All right. Get this straightened around here. All right. The first thing I have to do is calculate the slope. So these are pretty big numbers. So these you might want to use a calculator for. Or just because it's on a graph doesn't mean you have to count. You can do the subtraction. So I'm going to go from here to here. So my vertical movement, I subtract the y's. So I have 780, subtract 304. which happens to be 476. I wrote that wrong. I apologize. It's a subtraction sign. Then the other one is 5 minus 3, which is 2. Well, I can reduce that. I can divide 2 into 476. I get 238. There's my slope, 238. Now the y-intercept. This graph, if you look at it closely, crosses right there. That is 0. So my equation, y stays the same. My slope, my m, 238. The x stays the same. But it's time to be done. I'm making mistakes. Plus the y-intercept. And there you go. That's how you write slope-intercept form. You can do it if you're given the information. You can do it if you have ordered pairs, because you can calculate the slope now that you know that formula, or you can count on the graph. That will take you through the first 5 pages of the lesson, and the first assignment that you will do is including just that material.